Diagram shows 3 circles, each a radius of 4 centimeters, and I'm asked to calculate the area of the shaded region. Well, first of all, in the middle here, to calculate the area of the shaded region, I'm going to first of all calculate the area of this middle circle. Well, the area of a circle is pi multiplied by r squared. I know the radius of the middle circle is 4, so it's going to be pi multiplied by 4 squared. 4 squared is 4 times 4, which is 16. And 16 multiplied by pi gives us 16 pi. As my lengths are in centimetres, my area therefore will be in centimetres squared. As we're told, the centres of the circles A, B and C are such that ABC is a straight line, and we're told A to B is equal to B to C, which is 4 centimetres. Therefore, here on the left, I can see I can create an equilateral triangle. As I have an equilateral triangle, therefore I know that each angle in my triangle will be 60 degrees. To calculate the area of a sector, we know it's the angle, which in this case is 60. We always divide by 360 and then multiply by the area of a full circle, in this case pi times r squared. We know the radius is 4, so pi times 4 squared. Simplifying our fraction, we know 60 divided by 360 will simplify to give us 1/6. 4 squared is 4 times 4, which is 16. And 16 multiplied by pi will give us 16 pi. Hence, I'm going to have 16 pi over 6. Dividing top and bottom by 2, that will simplify to give us 8 pi over 3. Again, as it's an area and the lengths are in centimetres, the area is in centimetres squared. To calculate the area of the segment, we know it's the area of the sector, subtract the area of the triangle. We know the area of the sector is 8 pi over 3. Subtract the area of a triangle. We know the area of a triangle is a half AB sine C. As an equilateral triangle, we know all the lengths are the same. So it's going to be a half multiplied by 4, multiplied by another 4, multiplied by sine of its enclosed angle. Again, as an equilateral triangle, and all the angles are the same. So in this case, sine of 60. I should know my exact values. That sine of 60 is root 3 over 2. Leaving the 8 root 3 alone for now. I know that 4 times 4 is 16, and 16 times root 3 is 16 root 3. And the bottom 2 times 2 is 4, and 16 root 3 divided by 4 will give us 4 root 3. And as it's minus, therefore I'm going to subtract 4 lots of root 3. I'm now going to add the area of the sector, in this case 8 pi over 3, and the area of the segment, in this case 8 pi over 3, subtract 4 root 3. Well, when adding fractions, we must have a common denominator. As they have a common denominator of 3, I can just keep the denominator the same, in this case 3, and just add the numerators. In this case, 8 pi plus another 8 pi. They're like terms, they both end in pi. That will simplify to give us 16 lots of pi. So I've got 16 pi over 3, and I've still got minus 4 root 3. As I want to find the area of the 2 shaded regions, well, then the area of the circle in the middle is 16 pi. So I'm going to have 16 pi, and then I'm going to subtract. I'm going to have 4 lots of my sector plus my segment. So I'm going to have 4 lots of, in single brackets, 16 pi over 3, subtract 4 root 3. Leaving the 16 pi alone, expanding my single bracket. When expanding a single bracket, I multiply whatever's directly outside by each term directly inside my single bracket. So negative 4 times 16 pi over 3, that will give us negative 64 pi over 3. And negative 4 times negative 4 root 3, we know a negative times negative will give us a positive. Therefore, that will give us plus 16 root 3. Simplify my answer, i.e. collecting like terms. As they both end in pi, they're like terms. We'll know 16 pi is the same as 16 pi over 1. In order to add fractions, we must have a common denominator. The lowest common multiple of 1 and 3 is 3. So I'm going to change each of these to have a denominator over 3. What if I times 1 to get to 3? I've times it by 3. So hence I times the top also by 3 to keep it equivalent. Well, 16 pi times 3, that will give us 48 pi. I'm still subtracting 64 pi over 3. And I've still got plus 16 root 3. Hence, my final answer is going to be 16 root 3. As both my pi terms now have a common denominator of 3, I can just collect my numerators. So on the top here, I've got 48 pi, subtract 64 pi, which will simplify to give us negative 16 pi all over 3. As it's an area and my lengths are in centimetres, therefore my area will be in centimetres squared.